Hello, I am Olga Maryeva from Astronomical Institute of Czech Academy of Science, and I will talk about a star with long name Wray 15906, which is luminous blue variable that passed through red supergiant phase. Most red supergiant in end of their life explode as supernova. However, stars with initial mass in range between 25 solar masses up to 40 solar masses after red supergiant phase may evolve into less luminous LBVs and even into Wolf-Rayet stars. Evolutionary link between red supergiant and Wolf-Rayet stars is interesting, but this link still remains unclear. Among hundreds of known Wolf-Rayet stars in our galaxy, there is no object reliable known to come from red supergiants. Evolutionary models show that stars with 20-25 solar masses that come to LBV through red supergiant phase are so unstable that they explode as supernova right after LBV phase. Wray 15 attracted our attention after we discovered a circumstellar shell around it using WISE satellite infrared data. Its spectrum is rich with hydrogen and helium emission lines, and many of them display P-Cygni profiles. Since 2015, Wray 15 is included in the list of galactic LBV candidates. Comparison Wray 15 with Spectral or B supergiant clearly show that Wray 15 is a Wolf star. Its spectrum is enriched with nitrogen and helium. Also, we see that the star has higher mass loss rate than OB supergiants. Here is comparison Wray 15 with other LBVs. Classical LBV star P-Cygni and Wray 15682. We see that Wray 15 is intermediate between them. Like P-Cygni, it still doesn't have a helium-2 line, but like Wray 15682, it has higher wind velocity. All lines in spectrum are wider than in P-Cygni. We did spectral monitoring the star on SALT during the last 8 years. We found variability in spectral lines, appearance of additional components in P-Cygni absorption profile of some lines. Also, the stars show low amplitude photometric variability. Wray 15 lays between over LBVs in infrared two-color diagram. We calculate model of atmosphere using CMFGEN code. Here is a comparison between observed spectrum and best fit model. Here, comparison model spectral energy distribution with photometric data. We estimate luminosity, mass loss rate, effective temperature, and other parameters. Our modeling allows us to find position the star in Hirschsprung-Russell diagram. Wray 15 lays perfectly on evolution track corresponding to 25 solar masses. According this track, the star already passed red supergiant and now evolved to blue side. According to our study, we confidently classify the star as low luminosity LBV. It shows spectral and photometric variability. Wray 15 is the first LBV that is so close to theoretical prediction of low mass LBV's evolution that already passed red supergiant phase and evolve blue side, and will soon explode as supernova. It means Wray is unique object for investigation, the link between red supergiant LBVs and WN11 stars. Thank you for your attention.